So we'll probably get into our next module. All right. Hopefully everyone can see that okay. Rearrange some of the Zoom windows. All right. So we talked about reproducibility, but now we're going to get into something really important, which is data input. All right. So just a quick reminder before we get into it, and that is that you may be needing to get files from downloads to bring data into R. So maybe you don't have all the data you need for your project already living on your computer. If you need to download something from either our site or some other resource, Department of Health for the state of Washington, you're downloading data offline. Just remember, we have these resources here if you need help getting your files from downloads. Okay. So before we talk too much about data input, we want to talk about something called R projects. Okay, so what are R projects? This is not to be confused with an independent project. This is actually something specific to RStudio and the Posit company. So R projects are a helpful feature, like I mentioned. They're going to help you be able to stay organized. They're going to help you organize your work into a specific folder where you can keep everything, your data, your R markdown files. Basically, it's going to simplify your file management and help you locate everything associated with the project. And that project might be this course, for example. So it's also going to help you find the right files. So when you're bringing data into R needs to know where to look. And R projects are going to simplify that. And we just learned a lot about reproducibility. Projects can make your work more reproducible. Folks kind of know where things are, they know the file structure. Everything they need is in this specific folder that you could maybe even share with others. So before we get too deep into it, let's try to create our project. We'll go over that and we'll do that as part of the lab. So if you want to just follow along for now, that's totally fine. All right. So there's a button in RStudio that's going to help us create a new R project. And I'll go through this with all of us together, don't worry. We'll click on a new directory. We're going to make a new folder. We're going to make a new project. We're going to give it some details. So we want to name our project and we want to store it somewhere easy to find. This could be your documents. This could be your desktop, somewhere that makes sense to you to keep your projects. And then once we do that, we're going to have a new folder created, wherever we specified. In my case, I might want to create it on my desktop. And so it now should see a new folder on my desktop. And so as I go through, the rest of this course, or I'm doing a project later on, I'll want to add any R Markdown documents or data files to this folder. That's going to make sure that R can find those files. So let's go through that process together. And let me get rid of the reproducibility lab and clean up everything. All right. So I mentioned there's a little button. It's a little bit small, but it's right here. You can click that button or you can go to File, New Project. You can do either. So I'll go ahead and click that. You're going to click on Don't Save unless you have files you would like to save first. Again, we'll go through this in lab, but we'll click on New Directory, New Project, and let's say I want to call this Daisy course, call it October or something. And I want to put that on my desktop. So I'll go ahead and create that project. You can leave these unchecked. That's fine. All right. So a couple things happened. I now can see over here in this top right corner, it says the name of the project that I just created. And if I get things out of the way, I can see that I have that folder now on my desktop. So if I were to double click into that, it created this file called .rproj, and I could just drag and drop any data files associated with, my work here. I could just drag them and drop them into this folder. All right. Yep. So I mentioned you should be able to see what project you're working on in the top right corner. All right. So once we've set up our project, let's talk about actually getting some data into R. We want to start working with something that's a little bit more exciting than a vector of 1, 2, 3, right? That's not going to be super insightful as far as, we're doing really cool science here. We want to start to get some data into R. And so let's talk about what I'm calling the manual point and click method. Okay, so just to kind of center us here, data input's going to be the real first step of any sort of real project or analysis. So once we get to the codeathon portion of the DAISY course, this is maybe going to be one of the first things you do, is actually bringing data into R. The cool thing is that R can read almost any file format, especially if you install one of these kind of expansion packs, these add-on packages. So even things like Excel files, or if you're familiar with other tools like SAS or SPSS. And that being said, we're going to focus on more simple delimited files first. This is usually plain text, and each column is separated by a comma, something that you could open up in Excel. So typically these are comma separated files. They end in .csv, or tab delimited files that end in .txt. Okay, so what are we actually working with here? Let's talk about some of the data that we're trying to read in to R. So we're going to work with a data set that is about heat-related ER, emergency room visits, for the state of Colorado. So this could be really important. Heat waves may be getting worse or have coincided with fire or other kind of natural climate related challenges. So something that we may be interested in tracking. And so we're going to load this in, and it's going to contain age adjusted visit rates and total number of visits for all people of all genders by county for different years. Okay, you can learn more about the data here if you're interested. All right, so let's talk about how we point and click bring this data into R. We're going to use a URL to bring this data into R, so a website link. The process we're going to go through is by clicking File, Import Dataset, from text, read R. We're going to paste that URL. We're going to click Update and Import. And importantly, this is going to save data to memory in R. It doesn't put the data on your computer anywhere when you use a link. It's just going to bring it into R's memory. You can start working with it, but if you want to save that data, you either need to download it first or actually write the data, which we're going to talk about a little bit later in the course. So let's copy this link. We're going to need it to go through this process. All right, let's go back to R. I am in my project. I'm double checking that, so that looks good. So let's go to File. We're going to import dataset. I'm going to go to from text read R. It's going to open this nice dialog here. Okay. It's going to tell you, I want you to tell me a file on your computer, or I want you to tell me a link. So let's drop that link in there. Nothing is going to happen right away, but we'll want to make sure we hit the update button. Okay, so this is a really good sign. This looks like data, right? It's got columns, it's got rows. If you don't see anything there, it might mean you need to hit that update button. All right, so I'm going to leave everything as is. I'm not going to touch anything else. I'm going to hit that import button. All right, so a bunch of stuff just happened. So let's go over what all of that is. So first things first, it opened up a viewer of the data here. Kind of looks like a spreadsheet. It's got a kind of a tab I could close if I needed to. I have a new object in my environment, and it's actually under the data category. Before we had things under variables. This time it's data. It's going to tell me a little bit about that data set. And if I scroll all the way down in my console, I can see that R took the liberty of running some code for me. So it loaded a package, it created an object, and it opened a viewer. We'll talk more about that in a moment. So a lot just happened. Okay, and again, the data is in memory. I didn't save any files to my computer. All right, so just to recap, what happened? We have a preview, we created a new object, and we ran some code. And here is a GIF version of that if you ever want to revisit it. Okay, so that was cool, but we're not always going to have the link that we want to bring the data into R. A lot of times we're going to have data downloaded. It's going to be maybe it's private data, it's not just living out there on the internet. You can do a very similar version of this where you download the data, put the data in your project folder, and then basically go through the same process. You go to File, Import Data Set, you browse for the file instead of pasting the URL, and then you click Update and Import. So very, very similar. Okay, so a little bit of a gut check here. How can we get data into R? Would that be from a URL? Could it be from a file we downloaded? Or could we do both of these? Yes, exactly. We can do both. It's going to depend on our situation, which one we do. All right. Great. So with that, maybe we can pause here for our first break, and then we'll come back fresh, ready to practice this after about 10 minutes. Does that sound okay? All right. Let's go ahead and jump into those breakout rooms. Hey, everyone. Welcome back. Let us share. And we'll want to get the input lab. So if you go back to the class website, materials and schedule, that's right there. I'm going to go ahead and download that and open that up. Get rid of that tab with the data on it. Gonna get everybody's windows in order. Yeah, that's fine. I think, yeah, you can use the same project for the rest of the course if you want. I would say that probably one for every module is like overkill. Yeah, so I would probably just use the same one. Maybe when you do the Codathon project, that could be a different folder, different project. Yeah, good question. All right. So some troubleshooting tips before we get started will be a little bit more relevant in a bit, but remembering that R is case sensitive, we're keep an eye on quotation marks, parentheses, that good stuff. And something I see quite often is actually a little bit of a deletion on a chunk. And notice that that made everything look very weird. So if you delete part of a chunk, just be aware that that might be what's going on. It's making things look a little funky. All right. So I mentioned we would set up our project. If you haven't already, let's do that. Let's make sure we get that set up and going. And so here are the steps. We went to File, New Project, or New Project button. That's this one right here, the little kind of translucent box with an R in it. You're going to hit New Directory, New Project, give it a name, and choose a location, and just double check that that folder is there. So I'll give us a minute to do that. And please let me know. I can't look over your shoulder. So if you're having any struggles, this is I will say that like this is not required to do R. So it's a little bit more tricky than just, typing in the console, right? But I do think it's going to set us up for success. So let us know. Let me know if you're having any issues. Okay. So I'll give us a minute to do that. All right. So can I see some thumbs up if we're feeling okay about setting up our project? Did it go all right? Okay, anyone need another moment? Yeah, it will close the file, so that can be a little tricky. Hopefully you can follow along with it on my screen and then reopen it. Yeah, that is kind of the bummer. It does help you keep your files organized though. If you have, let's say, like sometimes you can have like profiles on a browser. So you could like projects could be that way too. Like you have certain tabs that are open on one profile and certain tabs open on another. And that way you can keep things organized. So I wouldn't open up my genomics data in the DAISY course, for example. So it helps me stay a little organized. But yeah, once we have our project open, it shouldn't close any files out again. Okay. And so when we check that the folder is there, remember that I made mine on my desktop, so it should show up on the desktop. All right, let's go ahead and load tidyverse by adding library tidyverse below and running the code. Okay. So I typed in that code. What do I need to do now to make sure that it actually runs the code? Yeah, exactly. Could hit that, or I could do my shortcut. Sometimes I like to do the shortcut because it's a little speedier. So very cool that it showed me all of these core packages that I attached alongside Tidyverse is basically a big bundle of packages. And don't worry too much about these conflicts for now. All right. So now that we've got that loaded up, let's use the manual import method to read in the Cal Enviro screen data from this URL. So remember we used the URL when we did it in class when I was showing you. So a little bit about this. These data were collected by the California Office of Health Hazard Assessment to track environmental measures. And this is things like, air pollution, particulates, water contamination, lots of other things. Basically, any environmental measurement that can impact human health. And so you can read more about it here. There's also kind of interesting is that they put together all these measures and then they create a risk score based on all of those. So basically, do you live in an potentially environmentally harmful area? And so that way people can know about that and they can track it. All right. So let's take a moment and try to do the manual import method to bring in data from this URL. Okay. And so once you're able to get this to work, it would be great if you could just in the chat mention something that happened. It could be any of the things that we talked about. All right, we're seeing maybe some data visible in the environment, maybe over here. Maybe it's a little differently formatted. Yeah, that's definitely possible. New object in the environment. Perfect. New window with data opened. Yeah. Last time we did that in class, we were looking at that ER data and it opened up a spreadsheet for us. Anything else? Yeah, yeah. So we can see once we run this, we should be able to see how many observations and variables we have. All right, so I'll go through this and then hopefully we can diagnose any issues that we're having, okay? So let's use that manual import method. I'm going to copy this URL first. And so I'll go to File, Import Data Set, and from readr. Let me do that just again. That was a little quick. Sorry. File, Import Data Set, and from text readr. All right. I'm going to paste that link right there. And so, very important, if I don't see anything in the data preview, I need to hit update. All right. So this data looks a little different. If I scroll, I've got like a ton of columns in this data set. So I mentioned that it's like measuring environmental hazards and attributes. And so there's quite a few of those, right? Environments are pretty complicated. So a lot going on here. All right. So once I hit update, I'm going to hit import. Okay. All right. So, folks, it sounded like maybe we had maybe some formatting issues, or maybe you weren't able to read in the data. If you can maybe even share some errors in the chat or let me know a little bit more detail what's going on, hopefully we can help. Yeah, that's a great point. Yeah, you may have to install some additional packages to read things in, especially tidyverse. This is going to be really important. Hopefully that was already installed, but there may be a few more. Ah, yes, the original link. So this one right here. Yeah, typically if we're reading in from a URL, we'll want to check that file ending kind of makes sense. I know it can be really tricky too. And we're not always reading from a URL. That's not as common. So, yeah, looking out for that file ending should be helpful. Okay, great. Sounds like we did a little troubleshooting, and that's awesome. I feel like that is one of the hardest skills to learn is to kind of figure out what the issue was and try a couple things. So great work there. All right. Anyone want to tell me what this data set object is called? We should be able to see it in our environment or kind of take a peek at the console to figure that out. What's this object called? Yeah, exactly. So it's right here. It's CalEnviro screen underscore data. It's kind of a little bit of a mouthful. But yeah, so I should be able to see it in the code down here. And also if I look in my environment, I can actually adjust the environment margins here a little bit, or actually just like do this and check it out. Yeah, it's nope, not that link. It is CalEnviro screen data. All right. And so taking a look at the preview in the environment, how many observation and variables are there? Feel free to drop it in the chat, or if anybody wants to take a guess from the environment. What are dimensions that we're dealing with in this data? How many observations and variables? Yep. So looking at the data in the environment, how many observations and variables are there? For CalEnviro screen, how many observations and variables? Mm-hmm. Excellent. Yeah. So taking a look at our environment, we've got a little bit over 8,000 observations. That would be number of rows. Like this is a big data set. Not nothing to shake our head at. And it's got 67 variables, so 67 columns of the data. And then the question, the previous one. So were you talking about this question? Okay, so the 768, that was for this Colorado ER heat visits. That's a different object. It's a different data set in our environment. We're talking about the one we just read in. And when I'm saying looking in the environment, I'm talking about like this right here. And then you can actually also see this. This is super sneaky. You can see this in the console as well. All right. And so to make sure that we have that Cal and virus screen data, we'll want to do that manual import method. So dropping that link when we go through file, import data set, and from text read R. And that should hopefully give us the Cal and virus screen underscore data object. And so just in general, making sure that we can see the object in the environment. I know this seems like, well, we read it in. Like, why do we need to, report back what it's called? Why do we need to report back the observations and variables? It's a really good gut check, right? We want to make sure we read the data in. We want to make sure it was successful. All right. Any other questions before we head back to part 2? All right. Well, in that case, let's head back. We'll learn a little bit more and get to practice a little bit more. All right. Welcome back, everybody. So let's do a little bit more here and we'll continue with part 2. All right. While we were doing all that, there was a lot of clicking around, right? Like it was, we could kind of follow along, but it was, just a lot of clicking. And it would be kind of difficult for me to say, okay, Carrie, you need to click all these buttons if you want this exact data set. It's easy for me, but it might be hard for others to do. And it's kind of obscuring some of what's happening. So it ran a bunch of code, but it did that automatically. I didn't actually get to write the code. So let's talk a little bit more about some other ways we could read in some data. All right, so we're going to work on getting data into R directly. All right. So the tidyverse package that we mentioned, we actually loaded it up in the lab just previously. It's going to contain a package inside it called readr that's going to be really handy for importing data. It's going to have functions that we can use to do that. And so some of our code might look a little something like this. We might load up the tidyverse package, and we might use a function called read underscore CSV and tell it, okay, well, I want you to read a CSV from some source. I want you to read in a file from the internet from this URL. And I want you to call that file that I read in, I want you to call it DAT for data. All right, so how does this look in practice? And let me open up a new R Markdown just to kind of do some notes here. Okay. All right. So how do I use read underscore CSV? I might create an object called DAT, just like we created X's and Y's earlier. We're going to use the read underscore CSV function, and we'll tell it, I want that file to be a specific URL. And I am not expected to memorize this, right? So normally we can copy whatever that URL was and then paste it in. All right. So I've got this code here. I want to run the code. I'm going to hit that green play button. And very cool. I now have an object. I got to name it whatever I wanted this time, which was nice, right? It doesn't have to be called COER heat visits. So I read in some data using code all by itself, no clicking required. And in case we want to look at a little bit of the data in the console, we could use the head function. All right. So let's talk a little bit about declaring arguments now. So R is pretty smart as far as programming languages go. It's actually able to guess sometimes what you want to provide for an argument. So most of the time when we're doing read underscore CSV, we're providing a file name or we're providing a source such as a URL. And so they know that this is kind of the most important argument that we're providing. It's the first argument that we're providing. So if I want to leave off file equals, I can still read that data in. So if I wanted to take off that right there, R will evaluate it the same way. So sometimes I can get away with not declaring arguments. So you may see it either way. All right, so the source that you provide to read underscore CSV can be a link or it could be a file name. So as we mentioned, it could be data we downloaded on our computer. It could be a URL. Either one is fine. So you may see something that looks like this when it's a URL. And you may see something that looks like this if it's a data file that importantly, we want that in our project folder. Okay, so why do we want it in our project folder? This is going to get a little bit into a little computer sciencey background here. So when we work inside an R project, we made that folder. That project folder is something called a working directory. And so this is going to be a folder that RStudio is going to know to use to find your data. So if you have files that you want to use in R, they're data files, you might want to put them in your project folder because that is the working directory for your project. Okay? So let's actually see that in action. So right now I've got this project open called Daisy Course October. And actually, the cool thing is when I've opened up this project, it automatically shows me the files that are in that folder. And all I've got is this kind of project file. It doesn't really have anything important in it, just kind of maybe some settings that I might have that I like my RStudio to look like. So if I were to put some data in here, then it would be available for me to just pull in to R. So let's kind of see what that's going to look like. So let me go to my downloads. And we were working with this Colorado ER heat visits data. Here it's just a file that I basically downloaded. You could download any CSV file as long as let's hope it is not from an unsafe source, right? A safe data source. Department of Health is great, CDC, something like that, perfectly fine. But let me go ahead and put that file into my project file. And so this will look a little different if you have a Windows machine, but usually moving around files is pretty straightforward for both. But let us know, of course, if you're having any struggles. All right, so that file is now in my project folder. And notice I can now see it here. So this is going to be much easier for R to find. And so let's say, I've got my code here. And let me call it ER dat. I'm going to name that object ER dat. I'm going to read CSV. And because it's in my working directory, the only thing I need to do is give it the file name in quotes. But especially cool is I can hit the tab button and it will show me all the files that I have. So select the one that we're interested in, and the code is ready to go. So I can run this line of code. I could even just run the whole chunk of code. And so now I have ER.dat that got read in from this file. All right, so that's a little bit about how, it knows to look there because it's the working directory. And so sometimes we're not always super sure what the working directory is, especially if we're not working inside a project. Hopefully you are working inside a project. I think they're really helpful. But if we need to check the working directory, you can do that using getwd. And so maybe I just want to double check what's my working directory. That is the project folder that I made. So that should look familiar, right? I made it on my desktop and I called it DayZ Course October, or Oct. Maybe it's Octopus, not October. And we can set the working directory if we need to, right? This hopefully we don't need to do if we're working from a project, but if you want to point to a specific folder on your computer for R to look, you can use setwd, and you can tell it specifically where you want to look for files. All right, so we've been pulling a lot of data into our environment. We had the Colorado data, we had the Cal Enviro screen data. So we've got a bunch of data sets right now. But it's always important to check the data. We're going to say this over and over again, checking the data to make sure it's what we want, and talking a little bit about some other formats that you might encounter. All right, so really helpful function is the view function. It's going to show us our data in a new tab in spreadsheet format. And so just like, we don't want to open a giant file in Excel, be careful if your data file is really large, okay? So we could do view. Let's take a look at that ER dat that we just read in. All right, so it's opening up a little spreadsheet for us. Pretty nice. However, I can take a little bit of shortcut. Let me X out of this. If I just go over here to my environment, there is a little spreadsheet kind of icon here. If I just click on that, it does the same thing. It actually runs that code in the console for me and opens up that spreadsheet viewer. Looks like I've got some missing values. So we'll talk all about that tomorrow. All right, so view of the data set. All right, some other delimiters we might run into. So I mentioned that we might have tab separated files. We could use a very similar function called read_tsv, which will enable us to read tab separated or tab delimited files. Or if we have any data that has like kind of a funky delimiter, sometimes you might run into like a colon that's separating the different columns. Not as common as commas, but you can actually specify the delimiter or the separator with _delim. And so what do these pieces of code look like? It might look a little something like this, where you have read_tsv. You give it a file name that is either .tsv or .txt. Sometimes you see that. And it actually knows that the delimiter is a / and a T for tab. So you actually don't even need this part of it. you should be able to read it in OK. And so for read underscore delim, if you have kind of a different format, you'll still need to provide that file name, but then you need to be specific. You need to tell it exactly what is the separator that you're using for the data. But the format, I think, is kind of nice. It's a little bit easier to remember. It's read underscore something. So read underscore CSV is kind of the one I encounter the most, but you may encounter these as well. All right. So there are also other file types you can read into R. So the read Excel package can read Excel files, which is pretty nice. I know a lot of us have data that is stored in Excel. And let's see, questions in the chat. Looks like it was answered. So the Haven package has some functions to read other specific formats, specifically data from SAS or Stata, some statistical software packages that are kind of common in some fields. And I know we do have some folks who are interested in kind of more clinical data, and REDCap is often used for some of those resources. There's also a package called REDCap R. I personally don't have a ton of experience with that one, but I know that some folks use that quite a bit. All right. So a little bit of clarification here. So you may run into or see a function called read.csv. I know it's so similar, right? It's dot versus an underscore. So read.csv is base R. It's not part of the tidyverse. And these kind of follow a similar convention. They look like read.delim, read.csv, very similar to the functions we were just talking about. They're going to have a slightly different syntax. So that means that what the arguments you provide and the rules that you need to give it are going to work slightly different. So it might not read in your data exactly how you want if you use the same code otherwise as I'm doing. So, let's say, we're coding, I wrote this here, and you wrote read.csv. It might not read in the data exactly the same. So just be aware, check out the function that you're using, just make sure it's the same one I'm using. And while it's not necessarily wrong to use the read.csv, the base R version, the ones from tidyverse and specifically that readr package, those import functions are a little bit faster, and they're the ones we're going to use, and they work a little bit more nicely with some of the other tools that we're going to use later on in the class. So just be aware, you may run into this. It may cause some issues. So just double check for that period there versus the underscore. All right. And so if you're really excited about this knit functionality too that Carrie talked about yesterday, generating this a really nice report, you can go and send it to your coworker, or you send it to your classmate, you're working on it in class or something like that. You may have to specify the knit directory. So sometimes it doesn't by default know to work from your project folder. So you may have to kind of play around with these directories here just to make sure that the knit works correctly. All right. So again, very important to look at our data. There's a couple functions that can help you do this. We mentioned the str, the structure function, because it tells us about basically the structure of an object. It tells us how long it is and what kind of class the object is. So we could use str. We could use that on a data set if we wanted to. And we'll also talk about the glimpse function a little later. This is a really nice one for just getting a summary of kind of what your columns are. What do your columns contain text or do they contain numbers? And also the head and tail functions, which are going to show us the first few rows or last few rows of data. So if I go back here and I want to say, all right, well, what's the head of this ER dat? What am I getting myself into here? I can see the first 6 rows of the data. And likewise, if I want to look at tail, I could look at that as well. Looks like I'm missing some data. All right. And similarly, I could do str. And this is going to give us actually a little bit more information than if we had just a simple vector. So it's showing me that it is basically a very special data frame, or kind of like a spreadsheet. We'll talk more about that in a bit, but it's got columns county, rate, it's got these confidence lower and upper, number of visits, and the year. And if I go ahead and check this data out over here, that should track with what str gives me. Okay, so just a couple ways to kind of confirm what I've got going on and that the data looks how I want it to. All right. So let's talk a little bit about just recapping what we did. So our projects can make it easier to find files, and you can import data manually. So we can go from file to import data set to from text readr. We can paste that URL and browse for the data, depending on kind of where our source is. You browse for a file. We'll want to make sure we click update and see a preview of the data and click import. We can also review this process at the link here if you want to refer back. But it's going to be a little easier for others to follow along with what I did, and actually faster for you in the long run. Once you have the code down, all you have to do is hit the play button. And that is read_CSV, which is a function from tidyverse, specifically the readr package. And you can use getwd to check your working directory, which is where R is going to look for your data files. Okay, it's so important to look at your data, right? We want to make sure we read it in correctly and we're able to start doing some cool stuff with it. So check your environment that you have a data object. Remember, we were looking for that Cal Enviro screen object in our environment. It was good to confirm that it was there. And we can also either click that little spreadsheet button, or we can do view of that object to give us a preview of the data in a new tab. And finally, there are other file types we might encounter. You could use read_delim for really general purpose. If you have separation of your data with different kind of characters, sometimes you might have a colon, sometimes you might have a different symbol. And there are other packages out there if you have more complicated files. Generally, if you're, working with something really complex, something really specific, you could even just Google that file type, and reading into R is a great place to get started to try and find a package that might help you out if you have a very specific file type. And then finally, don't forget to use the assignment arrow to assign your data to an object. Sometimes I do something accidentally that looks a little bit like this, where I just do read_CSV and just run the code. It reads the data and then doesn't save it in memory. So it just read it and then it evaporated. Sort of like, if let's say I'm really sleepy and I'm reading a news article, but then I totally forget it, kind of like that. So here I read it in, but I did not save it. So make sure that we give it a name. All right. So I did want to point out that Posit has a import cheat sheet that is really nice. So it's going to go into more detail than we covered, but they talk about read_CSV. and a couple other functions that might be helpful for you. And then we have our day 2 cheat sheet. So all the functions we talked about today, a nice review of all of that. All right. So I think we're maybe a couple minutes before our next break. And so how are we feeling? Do we want to get into part 2 of the lab, or would we rather have a break now? Yeah,
Uh,
so the link that was in the slide, so if we go all the way back, I think it was like slide 10, or let's actually go back here. Got to backtrack just a bit. If I click this, it downloads it for me. So I can actually put this link in the chat, and hopefully if you click on this, it will download that file for you. Sure. Other questions? It sounds like maybe we're excited to move on to part 2, which I love the enthusiasm. Breaks are important, of course, but sometimes we want to get a little practice before we get distracted by other stuff. I know I personally do.
And remember that you can visit Elizabeth in the breakout rooms if you need one-on-one attention and need help figuring out where to find your files on your computer. It sounds like maybe some folks are having trouble finding the lab file too. We can put that in the chat again as well.
Yeah, let's do that. Yeah, thank you, Elizabeth.
And again, they're always also on the website and the slides as well.
All right. Well, that sounds good. Let's go ahead and get a little bit of practice. All right. How we feeling? Nervous or excited? I got a thumbs up. That's good. That's good. Awesome. All right. So I promise we'll have practice doing this. So let's go back to the lab file. It sounded like maybe we were having a little trouble getting that. So we're back where we were previously. All right. And feel free to save this file. I'm going to go ahead and save it now. You can hit that save icon or go to file and save. And yeah, somebody I think said that it was hard to follow without the lab file. Maybe we can get a little bit more detail what's going on. All right. And then looks like question, let's go back to this file that we read in earlier. So we were looking at that Colorado ER data set in the lecture, but for part 2, we're going to go back to that data set we were working on before. Yeah, we hopefully you don't have to do anything without the lab file. That should hopefully be available for you and open up in your new project. What I was doing kind of in the lecture here is I had opened up a new R Markdown file and was just kind of like typing my code in it. And so you're welcome to kind of put some of that in the lab file or in another R Markdown file. Maybe you have one called notes or something like that. That would be fine. Yeah, so for part 2, yeah, let's look at the Cal Enviro data. Yeah, so for part 2, let's read in the Cal Enviro screen data from a URL. We'll use read underscore CSV, and we'll use this URL. And we'll actually assign it to an object named CES. Use the code structure below. So I'll give us a minute to kind of play with that, see if we can get that in the code there. And so very similar to what we did to the point and click method, but this time we're using some code to do it. All right, and we're using this URL to read in the data. All right. So show of thumbs up if we were able to create a CES object in our environment. Were we able to get that? Okay, got a couple folks. All right. Would you be comfortable sharing your screen? Maybe we can figure out what's going on. Okay, so I'm looking at your console and you read in dat with the arrow and the read CSV. That looks like that went okay. So like, let me get my pencil out here. Like this part went okay. That looks good. And let's see. Maybe you can show me the part in the lab if you go scroll down just a little bit in like this part. Mm-hmm. A little bit more. Uh-huh. Okay. Yeah, so looks like just the code looks great and maybe just changing a couple things. So what we want to do is put everything starting here. We want that inside the code chunk. So yeah, just this piece of code here. Yep, highlighting that and putting it right here. Yes. Yeah. So, yep, this part here, if you can copy that and put it right in here between these, which indicates the chunk. Oh, that's okay. Yeah, so maybe I can go through it and then let me know if we're still having some issues, okay? So if you don't want to stop, that's okay. Yep, Zoom's message settings can be a little funky. Yeah. So do you want to would it be more helpful to watch me go through it and then we can see if we're still having any issues? Yep. So you were doing it right. So I guess maybe you're not seeing my annotations on the screen. So sorry about that. All right. Let's stop your sharing and I will go back to mine. All right. So what I was mentioning just a moment ago, if you have code right here or text, it's going to kind of break up your code chunk. So you got to get rid of that and put it inside the code chunk here. All right. So let's create that object CES. And we'll use read underscore CSV. And in this case, we're going to read it in from this URL. And I want quotes because that is a piece of text. And so let's see how this goes. Let's try to run this piece of code. All right. So that should have given me an object CES in my environment. So I'll copy and paste that in the chat in case that's helpful. There we go. All right. So taking a look at some of the data, we created object cal envirus screen underscore data and CES. Do they appear to be the same when we take a look in the environment? Why or why not? Any guesses here? Cal envirus screen data and CES. Do they look the same? Yeah, absolutely. I would say, even without looking at it, I'm looking over here in the environment and I've got the same number of rows, the same number of columns. So that's a pretty good indicator. I would think that that could be meaningful. And I might even, click on the table button to kind of preview. So looking at that, and then maybe open up CES as well. And if I toggle back and forth between these tabs, they really do look the same, just looking at the first couple lines. So yeah, I think they are the same. And knowing that they came from the same URL, that's also a pretty good indicator. So I would say maybe same dimensions. All right. So last thing, and then we'll try to troubleshoot any questions that folks are having. So let's learn our working directory by running get wd with parentheses. This is where R will look for files unless you tell it otherwise. Okay, so this is really just nothing fancy as far as the code goes. We're just going to copy it directly. And then you can either hit the arrow or use your shortcuts. And my working directory is the project folder. Hopefully, if you were able to set up that project successfully, it also points to the place where you put that folder. So take a moment, see if that makes sense. All right. Any questions about these or maybe even the practice on your own? All right. Well, we have a little bit extra time today. We kind of built it into the schedule because reading in data can be pretty tricky. So if you're having any struggles, that's totally fine, totally normal. We can help work through them. But if you're feeling pretty comfortable, maybe you've had a little experience working with R before, you're welcome to head out unless you want to discuss any of these practice questions or anything else we've discussed so far. Yeah, so let's run this. Let's see what happens. Yeah, it looks a little messy. So looks like I have, let's like take a look at the dimensions really quick. It looks like I've got a little over 8,000 rows, but then I only have one column. Yeah, so that's a problem. So it looks like what's happened here is I gave it the wrong delimiter. So it's, I told it was a tab. It should look for a tab to separate the data, when in reality, it's a comma. And so this is where it's kind of important to check out that data, just make sure you're using the right file format. Yeah, so it is a little bit messy, right? Because reading it in with the wrong separator. So if we read it in with a comma
Yes.
instead, it should be a comma, right? Then that looks a lot better, right? Like it's actually got all 67 columns. It separated it out appropriately. So just like, if we were to read in data into Excel, we would want to tell it exactly like how the data is separated. Sorry, maybe to understand.
Uh,
Yeah, so let's say I went to file import from read R. If I browse, I can do that. That's fine. I can browse for it will take me by default into my project folder, but if I had something in downloads, I could read that into. Oh, okay. Yeah, so sometimes folks have a
when
little
I
bit of
when
issues with the URL. Okay. Yeah, so sometimes there's like, firewall or some kind of protection from using URLs.
Okay.
Generally, like if you have the HTTPS, it works okay. But yeah,
Okay.
if ever you're having a problem with a URL, you could just click it to download
Okay.
it. And then, like you're saying, you could browse
That's
for it or
I
read it in
understand.
directly. Yeah. All right. No, you don't need to create a different working directory unless that's sort of like just in case you need to manually tell R where to look for your data files. Setting up a project should be good enough in most situations. Okay, other questions? And like I said, folks are welcome to hop off if you're feeling pretty comfortable with it. Sometimes it can be a little tricky or there's just something teeny tiny that is a little bit off. And if that's the case, happy to share screen with folks. We'll work through it. And again, the answer keys to all this stuff is online. So in case it's just like not working, like sometimes, I'll be reviewing something new and it is just not computing at the time. I'm not getting it. And then I have a moment of realization at like 8 p.m., right? Sometimes it just doesn't work with the timing, right? Maybe you're not a morning person or something like that. The keys are online if you want to revisit anything we did today. So I will hang out if there's any additional questions, but like I said, up to you whether you want to hang out for a little bit. I will stick around for questions. Yeah, you can use whatever you have, but if you want to practice, I'm so glad you asked. There is a data tab on the website. So if there's anything you're interested in particular, personally, I'm very interested in the, climate change related, extreme events, so things like hurricanes and things like that. So that's like what a lot of my work is on, but if you're interested in more like healthcare stuff, there's a lot of that. Yeah, so that could get you started. Yeah, of course. Yeah, so this is a like an option you can have when you read in the data. It's not an error or anything like that. It's just telling you that you have an option to read it in and display different stuff in the console. Yeah, so
Mm.
so that's a or actually do you want to maybe share your screen so we can see what you're seeing? I see the exact same message when I read in the data and it's not an error. It's just yeah, like I said, you can be more specific in how you tell read delim to function, but it's not required. You could try to include show call types equals true. So that could, if you scroll up a little bit, so it wouldn't go in the console by itself if you scroll up a bit and a little bit more. And go to where it says delim equals tab. So right before the closing parentheses, one more to the right. Sorry, to the right. That's okay.
Here.
Go ahead and put a comma and then yeah, exactly. Show
Oh.
call. No, yeah, it's tricky. And then all caps true. So what does that give us? It's not really that different. So it might be if you change that T to a
Oh,
comma, it might be more helpful. So like right now it's kind
Yeah.
of the messy data, right? Still? Yeah, exactly. So let's change that to a comma.
And
So I'm trying to see if it is giving me any different because I might have slightly different settings on here. Okay, sorry. So if you put show call types equals false, so if you go
Mhm.
back up to your code, if you put false, it just quiets the message that it gives you. So it just gives you less stuff in the console. Yeah, so it's really like not going to change the way your data is imported. It's just like if you see where it says like around here, it's like the what is a number column and what is a text column. It's just if you want to get rid of that
Okay, got
message, you
it.
can. Mm-hmm.